Okay, everybody, welcome back to this Functional Life Brain Candy. So, we are continuing on with the 12 myths that people miss and that you don't know about women over 40 and our weight loss. And so, today I'm going to cover myth 10, 11, and 12. So, if you haven't listened to the other podcast shows where I go over each one at a time, I think it'd be a really good time to really check it out. And this thing is freaking the fuck out. Hold on. All right, welcome back to Brain Candy Bits. We are going to continue on with our 12 myths to weight loss for women over 40. And so if you haven't listened to those previous episodes, please go back because there is a layering effect of the misinformation and the science that you need to know to understand what's really happening in the body. And today we're going to cover myth 10, 11, and 12. So this is going to get a little bit geeky because now we're going to get into the inside of the cell. So earlier we were talking about the influence of hormones and metabolism and what you eat, macros like fats, carbohydrates, proteins, relative to the execution of those hormones. And then when the cells actually receive those hormones as key, what turns on and what turns off. So we're talking about what's available outside the cell. However, hormones, particularly things like estrogen, when they click into the cell, they actually do things. They actually transcribe and cause other things to happen inside the cell. And there's some very specific things that happen with estrogen that is unique to a female. So we're going to cover those today because this for me was the clincher. It was the underlying mechanisms that was causing me to hold on to 30 pounds of weight that I could not get rid of, doing all the right things and having access to the best of the best in functional medicine. So at the end of the day, this was some of the missing links that I found while I was digging around in my PhD, looking at the intersection of hormones, metabolism, and even things like the mitochondrial metabolites and the bacterial metabolites in the body. So one of the things that we know is menopausal women, so women that have gone through the transition and have lost all of their estrogen, they often suffer from low energy, muscle weakness, tiredness, reduced exercise capacity. So they used to be able to work out harder, but their recovery stinks in comparison. And then they also get a greater susceptibility to weight gain. And we talked a little bit about that already, about what's happening outside the cell and other things. But what we also know is that there's an energy depletion due to mitochondrial dysfunction. So the mitochondria are the powerhouses inside your cell, and they do other things. But today we're going to really focus on the mitochondrial powerhouse. And we burn our fuel predominantly in the mitochondria, but it has to be with oxygen. And that's the only place in which we can burn fat. We can also burn glucose there, but we can also burn glucose outside the cell in a campfire. And we can also burn a thing called phosphocreatine. When you're doing high intensity intervals, or let's say you're running up the stairs as fast as you can, that's the same activity inside the campfire. And you can only do it for a short period of time because you are anaerobic at that moment, which means that you are not getting enough oxygen to fuel the mitochondria. So that's why you can only sprint upstairs for so long. We can't sprint for an hour. It's because we've moved to that campfire. We're producing a lot less ATP. We actually have an extraordinary uptick in the production of lactic acid, which causes the mechanisms of like slowing down, muscle pain, and that also drives muscle recovery. But so there's a mechanism there, right, of how we're burning fuel and where we're burning fuel. So what's important is fat only gets burned in the mitochondria, and that's through a process called beta oxidation, which is actually through oxygenation, through the act of breathing or respiration that a lot of that is occurring. And it's very important that that mitochondria work really well. So recent studies have shown that estrogen plays a regulatory role in mitochondrial function. Now, much of this was done in rats because, again, we have to look at things, euthanize them, look at what is happening in the mitochondria. So it's harder to do this in humans, but they did rat studies in both looking at brain function and mitochondrial function, and they've looked at it at energy regulation and the ability of a body to burn fuel efficiency. So let me say that again. Estrogen modulates various aspects of mitochondrial function, including the production of ATP. So ATP is our money for our energy, right? So the more ATP I make, the more money I make, the more I can burn, right? So I want lots of ATP and I want to be able to use it very, very easily. And it also affects the mitochondrial membrane potential. So it's actually the membranes of the cell and the membranes of the mitochondria, think of that as the walls, that all the information gets passed. So we have this kind of switchboard of information that's going back and forth between the membranes. And the more activity that's happening there, the more we get potential, the more we get activity. The other thing is estrogen seems to affect mitochondrial biogenesis, so the production of and creation of mitochondria, and the regulation of calcium concentration inside the mitochondria, which is part of the mechanism that sort of sparks up that power plant and helps it work. We don't completely understand what's really happening here, but it could be a little bit of genomics. So it might have something to do with DNA. And I can tell you, when we start looking at some of the DNA factors that are estrogen specific, there are probably interplays here, because certain genes like comethyltransferase are associated with increased risk of diabetes, insulin resistance, metabolic syndrome, cancer, weight gain, because it affects estrogen, and it probably does at the mitochondria. We just don't know that yet. But it could be, lots of other mechanisms. It may be the act of estrogen on the receptors themselves in the way that it speaks directly to the mitochondria. But it's all part of the ability for the body to make energy. And it also seems to affect oxidative stress, which is resting. So if the loss of estrogen increases oxidative stress and we lose estrogen, so now our powerhouse can't run very well, that's a recipe for weight gain that starts at the very cellular mechanics, regardless of what's happening out at the receptors and whether your fat cells can mobilize fat or whether your insulin can actually get glucose across the wall. It's truly affecting the actual cell itself. And it also probably affects other things like the encoding of how the messenger RNA, which, we can thank COVID for people understanding that there's a messenger RNA, which talks directly to the nucleus of the cell and influences mitochondrial function, because it also talks directly to the mitochondria. And so the estrogen is also talking directly to that function and creating oxidative stress in a thing called reactive oxygen species, which basically makes you more inflamed. And when they looked at rats, they actually found that when rats had normal estrogen cycles, so they had normal periods, they had enhanced mitochondrial function and a better ability to use oxygen to burn fat and burn glucose. And just the loss of estrogen caused that to go down. So let's look at what's really happening here. So to put that in a nutshell, without getting super geeky, it's the loss of estrogen inside the cellular mechanics, inside in the mitochondria, that actually affects how fast that engine runs, whether that engine can get enough oxygen to burn hotter, and whether that cell is actually making more toxic byproducts that will slow the engine down and also affect the detox pathways. There's probably a genomic activity here, genes that are probably amplified or not. But at the very end game, it is the change in our estrogen that affects the internal cellular mechanics. So the mitochondria are screwed up when you go through menopause. And of course, if it's fluctuating right before that, we know it's also happening. And when the mitochondria start to dysfunction, we also see a reduction in fatty acid oxidation. Like I said, fat burning sucks. And then we will also have inhibited insulin signaling, particularly in the skeletal muscle, which is where we need to burn most of our fuel. That is where the bulk of our activity goes. And we have less ATP synthesis, so we're not going to make enough energy, and we're going to have impaired lipid use, fat use, and our skeletal muscles are going to become slower and less functional and less able to burn. And there's also evidence that adiponectin, which is the fat mobilizing hormone, and its receptor is induced by estrogen, and it affects mitochondrial production, so making of more mitochondria, and that adiponectin positively influences insulin sensitivity when there's estrogen on board, but the loss of estrogen is actually increasing this. So this is huge. Because this, in a nutshell, explains probably why there is differences in how men and women burn fat and how men and women actually can make energy. Maybe it explains also why we have less capacity for physical activities. Let's face it, a physical man or a physical woman, a man, even at the same height and weight, is going to have more muscle. They're going to have better physical capacity because they have more muscle. They also have hormones that drive that activity. So there is a radical difference all the way down to the inside of the cell between men and women. And particularly as we go through those hormone shifts, that disparity becomes greater. right? Okay, so that's the first one. Our mitochondria are messed up. That's what you got to remember. They don't work as well as they used to because our hormone estrogen is changing, and that is exclusively to women. Number two, there is a switch called the fat switch, and we can thank Dr. Rick Johnson. I believe he's at a University of Colorado, and he was looking at the increase in a thing called uric acid and how uric acid has always been associated with obesity, diabetes, metabolic syndrome, hypertension, cardiovascular disease, cancer. Basically, the higher your uric acid goes, the more likely you are to have all of those conditions I just listed off. So the question really was, is uric acid a byproduct of those problems, or is it the cause? Well, Dr. Johnson and many, many other researchers across the world have been looking at this, and what they found was that uric acid in the bloodstream is a byproduct of uric acid produced inside the cell. And uric acid is produced when there's damage inside the cell. So we have a lot of RNA dropping into the cell. So the cell goes, oh my gosh, I've got something going on. I'm going to raise my uric acid, because inside the cell, it's protective. And particularly outside the cell, it becomes counterproductive. Why does it become counterproductive? So in this situation of, insulin resistance, diabetes, we know that there's a mechanism. What is that? Oh yeah, insulin resistance and fat weight gain. So what they found was that the increase in uric acid is the cause. It is the fat switch inside the cell in the mitochondria that actually turns the powerhouse down. Now, they went and looked at every other animal. So if it is an animal or a single cell organism that respirates, uses oxygen in any way, the mechanism in which that animal gains weight, particularly fat, is 100% controlled by the activity of uric acid inside the mitochondria. So let me give you a really good example, because I think this is a great visual. Uric acid inside the cell, inside the mitochondria, gets turned up. And what it does is it slows the powerhouse down. Now I want you to imagine every animal that we know of, some squirrels and chipmunks, bears that hibernate. They all gain fat in a very prescribed way. That prescribed way is by the increase of uric acid within the cell. And it is ancient, it is required, it's what allowed that animal to survive through millennia. So it's an adaptation to environmental need. Now, that also means that no other animal in the wild gains fat uncontrollably. Only the animals we feed. So we induce our humanized lifestyle. No animal gets fat though. There are animals that are bigger, but that's actually part of their body makeup, but they don't gain fat uncontrollably. And actually, when you look in animal studies, even if we force fed an animal, causing it to gain weight, as soon as it goes back to eating ad libitum, at desire, the animal goes right back to regular metabolic activities, loses all the extra body fat because their metabolism responds appropriately and goes faster to burn off the extra fuel. So what the hell happened to us? So we had an adaptation, I don't know, millions of years ago, and an adaptation from when we went from something that looked very ape-like to very human-like. We went through an ice age during that time period. And during that time period, we had to change to an enzyme called uricase. It was a gene also. So that uricase enzyme clicked in, turning on the ability to create uric acid inside the mitochondria to slow the powerhouse down. It's what allowed our ape ancestors to make it through that low food availability, freezing tundra. Now, that rocked like nobody's business when we were starving. It doesn't rock now, right? So in many cases, we have this fat switch inside the cell totally turned on all the time. And I've been watching this for years, and I've seen it play out with my clients. I've seen it play out with myself, and I've seen it reverse, even the cooler thing. So, what's interesting? So when you look at the research, one of the things that all you got to do is look this up: menopause and uric acid. And guess what? We as women have an automatic uptick in uric acid found in the bloodstream, easily done on blood work. It is higher in general just because we've gone through menopause. Very interesting. So what's really happening there? Why would a woman have an increase in uric acid inside her body just with the loss of estrogen? I believe, and no one's really looked at it, that estrogen receptor activity inside the mitochondria that we've identified in animals is part of, and maybe even separate, but in addition to, the activity of uric acid inside the cell. that turns down the powerhouse. And when we lose that estrogen activity, there is an uptick in uric acid production inside the mitochondria. So all of a sudden the cell slows down. And as you go through menopause, that just rapidly increases weight gain. So how do we raise uric acid? So the cell is going to be doing it anyway. And what the research currently shows is that if your uric acid on a blood test serum is over 4.4, your fat switch is on, totally on. So how do we raise uric acid? So uric acid is raised when we have high fructose corn syrup, fructose, alcohol, sugar, processed foods, chocolates, anything with sweeteners in it are going to raise uric acid. Also, some of the foods that we love the most, like charcuterie, salami, cheese, aged foods, even things like nutritional yeast, beer, wine, all contain yeast, which has a high level of RNA, which turns on our fat switch. And then the other more insidious stuff is if you're eating foods that are packaged, bagged, or labeled, chances are you're getting a high amount of food additives and food flavors, umami, soy sauce, MSG, texturized vegetable proteins. All of those things turn on the fat switch. So in somebody else that's 20 years old, they might be able to eat that bag of Funyuns or that bag of Doritos and have no effect. But in somebody my age, it might be just enough to throw that uric acid off and click in the fat storage every single day. So I want you to remember that because that's really, really important. And there's a whole mechanism in which your body can actually produce fructose out of glucose. It's called the polyol pathway. And it's a mechanism in which our body can utilize to make different forms of fuel to protect us in time of starvation. And so that fructokinase enzyme is amplified in somebody. And what they showed was in people that get primed for the turning up of basically taking the glucose in your bloodstream and converting it to fructose, which gets preferentially stored in the liver as fat and then made to a triglyceride and stored as fat, which is why you should never touch high fructose corn syrup. That mechanism is amplified in everybody probably living on the planet today, except for a small handful of people. But as we get older, it's amplified. So we have an increase in the ability to basically take glucose and make fructose out of it. There's another way we can do that. When we have glucose circulating, let's say we eat a normal meal with some glucose producing foods and we're dehydrated. At the dehydration point is when we can turn on the actual production of fructose from glucose. So you've heard that if you're dehydrated, it'll slow your metabolism by 30%. It does because it slows the metabolic engine. Think of that water as the water needed for your waterfall to turn the engines to get the windmill going. The more water you have, the better the windmill turns, right? That's your mitochondria. The other thing that really is happening, if you're dehydrated and you eat, you're also going to raise the amount of glucose in your body, converting to fructose. Also, that polyol pathway is an alternative burning pathway. It's not as ATP producing, so you don't produce as much energy. And you've got all these other mechanisms that you might be turning it up all the time. So you have to stay hydrated. You have to be aware of that. And guess what else turns on the polyol pathway? Fake sweeteners, particularly the sugar alcohols. Now, erythritol doesn't seem to do it as much as sorbitol, but it does. But particularly sorbitol turns on that polyol pathway and ramps up that activity. So for a lot of people that have been doing things like keto or low carb, only so long can we go low carb. And don't get me wrong, we use ketogenic diets and different things during different therapeutic times to help fix the body. And we rotate in and out of macros to create metabolic flexibility. The hormone reset program is completely designed so you can do that. But what happens is women in particular will cut out all our carbs and we can't handle not having the sweets because we're driven towards it. And especially if our period's coming and all those other things. So we make a bunch of keto friendly junk food made with a bunch of sugar alcohols. And we may very well be driving that polyol pathway. So that may be a huge problem, huge problem. So what we covered today in the last 3 stages of your hormone imbalance that causes weight gain, in the last 3 of the 12 myths was number 1, women do have a completely different cellular effect and cellular activity when there's changes in estrogen. And that change not only affects how the mitochondria runs, it affects ATP, it affects detoxification, it affects your oxidative stress. all which slows everything down, which makes what's happening outside the cell with the receptors and the hormones circulating 10 times worse. We also have an amplification. This is number 11, an amplification of uric acid production inside the cell, which shows up outside the cell, which downregulates your powerhouse just because of the loss of estrogen. And nobody's actually looked at it, but I guarantee you there's a relationship there because it's so abundantly clear that we see an uptick immediately at menopause in uric acid. And that much of the foods we eat, the additives we put in foods, and the things that we love are going to drive that uric acid up and basically turn on the fat switch like we're hibernating. And then the very last thing is a lot of the things that we want to eat that we try and make up for in our low carb lifestyle may contain sugar alcohols and may turn up the production of glucose into fructose, which preferentially gets stored as fat. And we have this problem perpetuating. And if we're a little bit dehydrated, that happens routinely all the time. And as women, we have an increased activity in the polyol pathway because of the loss of estrogen. So what I just covered here are 3 different major mechanisms that show that women have a completely different metabolic activity inside the cell relative to men because of our activities of estrogen, and particularly the level of estrogen over our lifetime, either the gain or loss of estrogen, particularly around perimenopause and menopause. All right. So if you want to go look at what may be going on with your hormones, particularly the major issues with the hormones outside the cell and what's your major hormone imbalance, even if you know you've got your estrogen stuff going on right now and your perimenopause and menopause, I want you to go to hormonereset.net, scroll down to take your hormone quiz and check that out, because that's going to help you tell you the big question. What hormones are out of balance? What messages are your cells getting that are completely out of balance? And that's going to show you your dominant one. There may be some other things that are showing up too. For instance, a lot of people show up with adrenal dysregulation, but they may also have obviously the stuff going on with estrogen and progesterone behind the scenes. And if you've been struggling with weight, this is why all of the hormonal things you may be doing, even if you're doing the right stuff, maybe you're adding thyroid, maybe you're adding bioidentical hormones, isn't working. And your low carb, high fiber, low protein and high fat or high protein, low carb diet may not be working because there's a whole bunch of other mechanisms that are at play that nobody's even looking at. So you got to test, you can't guess. You got to get to the right place and have the right guide that can help you walk through it, because all 12 of these things, different pieces of them are active in everybody. But which ones are dominant? That's what we need to know, because it's easier to address when you really know what's going on rather than guessing your way through it, which I would assume if you're listening to this, you may have been guessing your way through it. So I hope you found all of the 12 myths of weight loss for women over 40 really interesting, inspiring, and educational. And thank you for joining me on This Functional Life on our Brain Candy Bits. Have a really awesome day.